Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, data pipeline. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: explain the end-to-end data pipeline in Power BI from source to visualization. The pipeline starts with data ingestion, where Power BI connects to sources such as SQL, Excel, APIS, and cloud services using import, direct query, or live connection. Next, Power Query (M-Engine) performs cleaning, shaping, merging, and transformations before loading data into the model. The transformed data is stored in the VertiPack storage engine, which compresses, partitions, and optimizes it for fast analytics. Finally, the model is used to build reports and dashboards, which refresh on scheduled intervals and are consumed in the Power BI service or embedded applications. Second question: what breaks query folding and why does it matter for performance and refresh? Query folding breaks when transformations like index creation, row-by-row operations, custom columns using complex M logic, or merging with non-foldable sources are applied. Once folding breaks, the remaining transformations are processed locally in Power BI, significantly slowing the refresh. Without folding, Power BI must pull the entire dataset, transform it locally, and then reload it, increasing memory and refresh time. Query folding is critical because incremental refresh requires it, and without folding, incremental refresh will fail or process full data loads. Third question: how do data flows improve data pipeline reusability and governance? Data flows centralize Power Query logic in the cloud, enabling multiple datasets and reports to reuse the same cleaned, standardized data. They enforce consistent business rules, ensuring that all teams use uniform definitions and transformations. Data flows support governance by decoupling data preparation from report creation, giving administrators better control over lineage and dependencies. Because data is stored in Azure Data Lake, or OneLake in Fabric, it allows enterprise-level storage, documentation, and auditing. Fourth question: what is the difference between dataset, data flow, and data pipeline in terms of architecture? A dataset is the analytical model containing tables, relationships, measures, and compressed VertiPack storage used for reporting. A data flow is a cloud-based ETL layer that performs Power Query transformations and stores the output as reusable entities. A Fabric data pipeline is an orchestration service that automates tasks such as copy activities, data transformations, and scheduling across multiple lakehouse, warehouse layers. Together, they represent ingestion, pipelines, transformation, data flows, and modeling datasets in a layered architecture. Fifth question: how does Power BI handle schema drift during refresh? If a column is deleted, Power BI throws a refresh error because downstream steps referencing that column cannot execute. If a column is added at the source, Power Query does not automatically load it unless column names are not hard-coded. Example using select columns can block new fields. Data flows and datasets expose schema changes in refresh error logs, allowing developers to identify the exact step that failed. Using dynamic M logic such as table, Column names or schema-flexible transformations helps reduce failures caused by schema drift. Sixth question. What is the role of staging queries, and why do large enterprises use them? Staging queries act as raw, unmodified copies of source data, serving as a foundation for further transformations. They improve pipeline performance because multiple transformation queries reference the same staged data, reducing repeated source calls. Large enterprises use staging to enforce separation of concerns, raw data, staging, versus business logic, transformation layers. Staging also supports governance by enabling controlled data lineage, simplified debugging, and consistent refresh behavior. Seventh question. Explain the relationship between mEngine, Power Query, and VertiPack in the pipeline. The mEngine, Power Query, is responsible for extracting, shaping, and preparing the data using transformations written in M language. After the transformation phase is complete, the clean data is loaded into VertiPack, which compresses it using columnar storage. VertiPack performs advanced optimization techniques such as encoding, segmenting, and dictionary compression for lightning-fast query performance. Both engines form a pipeline. Power Query prepares the data, then VertiPack stores and accelerates it for reporting and DAX queries. Eighth question. How does incremental refresh work internally? Power BI divides the dataset into date-based partitions, with older partitions stored as static data and newer partitions refreshed incrementally. The configuration uses range start and range end parameters, which define the boundaries of data that should be refreshed. Only the partitions within the incremental window are reloaded, reducing refresh time and memory consumption dramatically. During refresh, the service automatically manages partition creation, pruning, and merging without user intervention. Ninth question. What is the importance of data profiling plus column quality in maintaining pipeline health? Data profiling provides visibility into nulls, distribution, distinct counts, and anomalies, enabling developers to identify issues early. Column quality shows errors, empty values, and valid records, helping ensure data integrity before loading into the model. These tools act as early detection mechanisms, preventing downstream errors during modeling, DAX, or visualization. Maintaining a healthy data pipeline relies on verifying data consistency, types, and outliers before loading into VertiPack. 10th question. How does parameterization improve the scalability of your data pipeline? Parameterization allows developers to switch between environments, dev then test then prod, without rewriting queries or reconfiguring sources. It enables dynamic data source connections, making pipelines flexible for regional datasets, date ranges, or client-specific data. Parameters improve performance by limiting data extraction to required ranges, especially in large fact tables. They also support automation scenarios such as templated data flows, deployment pipelines, and repeatable ETL patterns across projects. 11th question. Your query does not fold. How do you identify the broken step and fix it? I enable View Native Query on every step in Power Query. The step where the option becomes disabled is the point where query folding breaks. I then analyze the transformation applied in that step, typically looking for non-foldable operations such as added index columns, row-level iterations, or merging with non-foldable sources. To fix it, I either reorder steps so foldable transformations occur before non-foldable ones or replace complex M logic with source-side SQL transformations. If folding is essential, example for incremental refresh, I push logic down to the SQL database using custom SQL views or stored procedures. 12th question. You need to process 200 plus Excel files monthly. How do you build an automatic pipeline? I store all files in a single folder location, SharePoint or OneDrive or Blob, and use the folder connector in Power Query to automatically ingest all files. I create a function-based approach, where Power Query extracts one file structure and applies that function to all remaining files. I ensure consistency by filtering out temporary or invalid files, using metadata such as size, extension, or filename pattern. The pipeline becomes automated because every new file dropped into the folder will be included in the next scheduled refresh without manual intervention. 13th question. Dataset refresh fails in the service but works in desktop. How do you troubleshoot? I review the refresh history details to identify errors related to credentials, gateway configuration, or missing permissions. If the dataset uses on-premises sources, I check whether the gateway is installed, mapped correctly, and using the right authentication method. I validate that the path, privacy levels, and parameters behave differently in the service compared to desktop, e.g., local paths don't work in service. Finally, I verify whether API keys, database credentials, or tokens have expired or changed, which commonly causes service-only failures. 14th question. Your Power Query takes too long to refresh. How do you optimize the pipeline? I check for query folding and push heavy transformations to the source system so that Power BI processes smaller datasets. I enable load for intermediate queries and staging layers to avoid loading unnecessary data into the model. I remove step-by-step transformations that materialize full tables and combine them into more efficient, source-side operations. I avoid expanding large nested tables too early and instead filter rows and columns at the source to minimize data volume. 15th question. You have multiple sources, Excel plus SQL plus API. How do you design a stable pipeline? I build separate staging queries for each source so that each dataset is ingested cleanly before merging them. I ensure schema consistency by normalizing data types, column names, and key fields before performing mergers. I use parameters to handle connection strings, API URLs, and credentials, allowing the pipeline to run reliably across environments. I implement error handling logic for APIs, timeouts, retries, pagination, to avoid pipeline failure due to unpredictable API responses. 16th question. A column is removed from the SQL database. What breaks in Power BI and how do you fix it? Power BI refresh fails because Power Query steps referencing that column, such as expanded column or changed type, cannot be executed. Visuals, measures, relationships, or filters that use that column will also break and show errors in the report. To fix it, I edit the query to remove references to the deleted column, update transformations, and regenerate any dependent logic. If the column is business critical, I coordinate with the database team to reintroduce the field or provide an alternate field for the pipeline. 17th question. Your direct query report is slow. Which part of the pipeline do you analyze first? I start by checking the source database performance, because direct query always pushes queries directly to the source. Next, I review DAX queries using Performance Analyzer to identify inefficient measures or relationships generating heavy SQL. I examine the model design, ensuring relationships are simple, cardinality is optimized, and no complex bidirectional filters exist. Finally, I analyze whether the source tables require indexes, partitioning, or query optimization to improve query response times. 18th question. You need to maintain historical data. How do you build a slowly changing pipeline? I use incremental refresh to retain historical partitions while only refreshing recent data, ensuring history is never overwritten. I store raw snapshots or historical versions in dataflows or lakehouse tables, depending on the architectural setup. I design the pipeline to detect changes, SCD Type 2, by comparing current versus previous snapshots using surrogate keys and timestamps. The final model then exposes both current state and historical state data, enabling year-over-year and trend analysis. 19th question. Data flow refresh is slow. How do you analyze each transformation to find the bottleneck? I open the data flow in Power Query online and inspect each step, checking for non-foldable transformations that force the engine to process full data locally. I isolate slow steps by duplicating the query and testing refresh time of smaller segments. I look for heavy operations such as joins on large tables, custom M functions, or expensive column transformations. Finally, I optimize by pushing transformations to the source, SQL views, or splitting the data flow into staging plus transformation layers. 20th question. A business requires dev then test then prod movement of pipelines. How do you implement it? I enable deployment pipelines and create 3 stages, dev, test, prod, to manage datasets, data flows, and reports. I use parameters to dynamically switch data source connections depending on the environment. I validate each deployment stage by checking refresh, RLS rules, and functional accuracy before promoting to the next stage. For advanced setups, I integrate REST APIs or Fabric pipelines to automate deployment, scheduling, and environment-based refresh management. 21st question. How do you design an enterprise-grade Power BI data pipeline for 1 billion plus rows? I begin with a distributed data architecture, using Azure SQL, Synapse, Databricks, or Fabric Lakehouse as the storage and processing layer rather than loading raw data directly into Power BI. I implement incremental refresh with hybrid mode, allowing historical partitions to stay compressed while the latest partition uses direct query for near real-time access. Pre-aggregation tables, semantic models, and data marts are designed to reduce the volume of rows loaded into the VertiPack engine. The pipeline is optimized with column pruning, selective filtering, partitioning, and compression strategies to achieve faster refreshes and improved query performance. 22nd question. Explain the role of dataflows General 2, Fabric, and how they differ from classic dataflows. Dataflows General 2 store output in one lake, which enables direct access by lakehouse, warehouse, and shortcuts, making them part of a unified data fabric. Unlike classic data flows, General 2 supports parallel execution, higher compute capacity, and pipeline orchestration, enabling enterprise-scale ETL workloads. Gen 2 data flows can output to Delta tables, supporting ACID compliance, versioning, and high-performance incremental updates. They integrate tightly with fabric capacities, meaning compute can be scaled elastically based on workload demands. 23rd question. How do you build a pipeline that supports both real-time and batch ingestion? I use direct query or streaming datasets for real-time ingestion, enabling dashboards to update instantly from event hubs or SQL streaming sources. For batch ingestion, I implement dataflows, pipelines, or scheduled refresh, which load large volumes of historical and daily incremental data. The pipeline separates hot data, real-time, and cold data, historical, later unifying them in a semantic model through composite models. The architecture ensures reliability by decoupling ingestion methods, allowing real-time updates without impacting batch processing performance. 24th question. What is the impact of disabling enable load for queries in complex pipelines? Disabling enable load prevents intermediate queries from being loaded into the model, which significantly reduces dataset size and refresh time. It forces queries to act as staging layers, allowing multiple downstream queries to reuse them without duplicating data. In complex pipelines, it improves memory efficiency by ensuring only final curated tables are loaded into VertiPack. However, disabling load incorrectly may break dependencies, so it must be used strategically alongside reference queries. 25th question. How do you merge Power BI pipelines with ci/CD and deployment pipelines? I use Power BI deployment pipelines to manage dev then test then prod transitions for datasets, reports, and data flows. ci/CD integration is achieved with Azure DevOps or GitHub, storing Power BI assets, PBIX, JSON metadata, in source control for versioning. The pipeline uses automated scripts or REST APIs to update parameters, refresh datasets, and publish content programmatically. Validations such as RLS checks, refresh tests, and model comparisons ensure that deployments are consistent and error-free. 26th question. How do you monitor refresh failures using the Power BI REST API? I call the getRefreshHistory API to retrieve details about failed or successful dataset refresh operations on a scheduled basis. Custom monitoring dashboards are created using Power BI itself, pulling data from the API to display refresh metrics, error messages, and duration trends. Alerts are configured using Azure Logic Apps or Power Automate to send notifications when refresh failures occur. This approach provides enterprise governance by enabling centralized monitoring of all workspace refresh activities. 27th question. How do you handle API rate limits in a Power BI data pipeline? I implement pagination, throttling, and retry logic within Power Query or data flows to ensure the API is not overloaded. Long-running ingestion is offloaded to Azure Functions or Fabric pipelines, which can manage concurrency and back-off strategies better than Power Query. API calls are scheduled during low traffic hours or split into smaller batches to prevent exceeding rate limits. Where possible, I cache API results in a data lake or SQL table, reducing reliance on frequent API calls. 28th question. How do you design a pipeline that supports multilingual or multi-tenant datasets? I create separate parameterized data flows or semantic models where tenant ID or region drives the filtering logic. Multilingual support is implemented using translation tables, storing localized labels and using modeling techniques like field parameters. Row-level security ensures that each tenant only sees their own data, enabling one shared dataset serving multiple tenants. Metadata and naming conventions are standardized to ensure smooth switching between languages or tenant contexts. 29th question. What strategies help optimize incremental refresh for large fact tables? I apply source-side filters using range start and range end to push the filtering down to SQL or Lakehouse instead of Power BI pulling full data. Historic partitions remain frozen and not refreshed, significantly reducing overall refresh duration. I tune the partition grain, monthly or weekly partitions, for optimal performance depending on the volume of data. When using direct query plus import hybrid mode, new records load in near real time while old partitions remain compressed for reporting. 30th question. How do you follow best practices for storing intermediate or staging data for reusability? I store staging tables in dataflows, Lakehouse, or SQL views, ensuring that multiple pipelines can reuse standardized, cleaned datasets. Staging layers are always designed as raw or lightly transformed data, ensuring traceability and ease of reprocessing. I disable load for staging queries inside Power BI Desktop but keep them available for reference, preventing unnecessary model bloat. Documentation and lineage tracking help ensure staging objects are maintained, monitored, and reused across teams. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.